Okay, guys, we're going to start our 1-2 with the factoring. This is all about solving quadratic equations. Remember, the quadratic equation is the equation that has that x squared on it, right? And our formula, or not our formula, but our standard position is ax squared plus bx plus c equals 0. And we set it equal to 0 because when y equals 0, we are solving for that x coordinate. So we want to remember that what we're actually doing is solving for these points. We want to know what this x is and what this x is, because it makes that parabola. Sometimes, most times, you're going to have two of them. Those are our x-intercepts. That's the whole point of solving a quadratic equation, is to find our x-intercepts, where our graph crosses the x-axis, right? All right, so factoring. First off, we have those kind of equations like x squared minus 8x equals 0. Well, we don't have a trinomial here, not the c is missing, we just have a binomial. So we do have a common factor, though, in both terms in the x. So we're going to factor out that x and always look for that common factor. I don't care what it looks like. You always want to look for and find any common factors in your quadratic, and that way sometimes you can just even simplify it down. X minus 8 is what's left, is equal to 0. Now the thing is that 0 is so powerful. If I have A times B is equal to 0, I may not know what A is, I may not know what B is, but what I do absolutely know is somebody's got to be a 0, right? There's only one way that you end up with that 0 out there, is if A equals 0 or B equals 0, right? Somebody's got to be a 0. Well, that's the same reason. That's our rationale for why are we going to do our next step. We have to set both x equals 0 or x minus 8 equals 0. And we solve. We don't have any solving for this one. X equals 0. Here we have to add that 8 to both sides. X equals 8. So if I were to be, when I go to graph, and I have this for a quadratic equation, I know that when my parabola comes down and goes back up, it's going to come down where x equals 0, and it's going to go back up where x equals 8. That's what we're solving for. There's my solution set. X is equal to 0 and x is equal to 8. Sometimes when we have that trinomial, those three terms, and a is equal to a 1, let's say I have x squared plus 2x minus 3 equals 0. I'm going to factor this into two binomials. Remember, we're doing that FOIL thing backwards. And what I'm looking for is two numbers that when I multiply them, I will get a negative 3. But when I add them, I will get a positive 2. I want to multiply to that negative 3, because remember in FOIL that would be our last term, right? So I want to multiply to that negative 3, but I want to add to a positive 2. And if I do a positive 3 times a negative 1, the negative 1 times 3 gives me the negative 3, and negative 1 plus 3 gives me the positive 2. So since my A was 1, I can go ahead and put my x's in. And then I'm going to have plus 3 because it's a positive 3 and minus 1 because it's a negative 1. And I can FOIL that back out and I will end up with my same equation. X times x is x squared. 3. And then my inside and outside terms is going to be plus 3x minus 1x. So I go right back to x squared plus 2x minus 3, right? All right, so let's finish factoring that. X plus 3 times x minus 1 equals 0. So there's my a, b. A times b equals 0. Somebody's got to be a 0. So I'm going to say x plus 3 equals 0 and x minus 1 equals 0. Subtract that 3. X equals negative 3. Add that 1. X equals 1. And this last step, over and over and over again, guys, I will see everybody do exactly the right work, but on a multiple choice test, they will pick that positive 3 and that negative 1 every time. You cannot forget to do this last step because the answer isn't a positive 3, it's going to be a negative 3. All right, sometimes when I'm doing a quadratic equation I'm trying to factor, it doesn't look like the quadratic equation, right? So just got to clean it up. There's nothing different here. They're just adding a few steps in. Distribute. So now you've got x squared minus 12x plus 27 equals 0. And again, okay, I am looking for something that will multiply to 27. Two numbers, something that's going to multiply to 27, a positive 27. But when I add them, I'm going to get a negative 12. And that's going to be a negative 9 and a negative 3. Negative 9 times negative 3 gives me a positive 27. And negative 9 plus negative 3 gives me that negative 12, right? So A is 1, so I can just put my x in, right? And then I've got minus 9, minus 3, whatever order you want, don't matter. X minus 9 equals 0, x minus 3 equals 0. Add that 9 to both sides, x equals 9. Add that 3 to both sides, x equals 3. So my solution set is the 3 and the 9. Okay? That means when I graph this, my parabola is going to cross the x-axis at x equals 3 and x equals 9. Right? You're going to want that business in chapter 4. So that's just kind of a look ahead. All right, so one more thing before I close out this one. In all of these examples we've done so far, our a has always been equal to 1, and we've been able to just place our x. But what if it doesn't? So what if I have 2x squared minus 5x minus 3 equals 0. A is not equal to 1. I'm going to do my same setup, my same little, but this time I'm going to multiply for this box here where I want it to come together as a multiplication. I'm going to multiply A times C. So I'm going to say 2 times negative 3. And that's going to give me a negative 6. And that's going to give me a negative 5. So this time I want two numbers that will multiply to a -6 and add to a -5. And that's going to be -6 and +1, right? All right. So here's my two numbers. This is what I need. I'm going to write down 2x squared, and I'm going to write down that -3. But instead of writing down a -5x, I'm going to write down -6x plus 1x. I got those numbers from inside this box here. -6x plus 1x. Now, I don't know if you remember from days of old, but when you have four terms, then you're going to group them, right? So I'm going to say, now, common factor for 2x squared minus 6x is going to be a 2x. And that's going to leave me with x minus 3. I already have an x minus 3 over here, so I'm going to just pull out a 1 because I don't want anything inside here to change. X minus equals 0. All right, now I have two terms, 2x times x minus 3 and 1 times x minus 3. My x minus 3 is a common factor in both terms. So I'm going to pull that out. X minus 3. Pulled it out of both of those. All right, and then that's going to leave me with 2x plus 1. Now remember, guys, we are never going to do all of this extra if a starts out as a 1. This is when a is greater than 1, and I have to break it down more. All right, so x minus 3 equals 0, and 2x plus 1 equals 0. Add that 3. X equals 3. Minus that 1. 2x equals -1. And divide by that 2, and x equals a -1/2. So my solution set is -1/2 and 3. Okay? And if you want more practice on that, there's some good YouTube videos called the AC method. And that might help if you need some more practice on this. But like I said, all of this, creating the four terms, breaking down your center term into two separate terms, is called the AC method. Okay. All right, and I'm going to talk about more methods in more videos, but we're going to close this one right now.